In this video, I want to talk a little bit more about capacitors. I have few capacitors. Okay, let's use this one. This is a 4700 microfarad 16 volt capacitor. Let's charge this capacitor. I'm just connecting this on the breadboard, and I have a multimeter here, and these are the probes. I'm connecting the multimeter across the capacitor just to check the voltage across the capacitor. Okay, my multimeter shows 1.26 volt. Okay, let's discharge the capacitor fully, just using these wires across the capacitor, and I'm just short circuiting. So now my multimeter showing 0 volts. So this capacitor is fully discharged. Let's charge this capacitor using this 9 volt battery. Connecting this to the power rail. Okay. Now the voltage across the capacitor is 0 volt. That's what my multimeter is showing. I'm connecting to the battery, then this capacitor will charge. It's already charged 9 volt. It didn't take that long, it was so fast. Now it's 9.26 to 7 volt. Now this capacitor charged. Let's discharge this capacitor to an LED. Now the capacitor charged to 9.31 volt. I'm removing the battery or the power supply. My multimeter is still showing 9.3 volt. I'm just going to discharge this capacitor through this LED. Connecting. You can see the voltage is going down and down. And it's going to 0 gradually. It will eventually reach 0 at some point. Now what I want to do, I just want to connect or charge this capacitor through a resistor. So I'm just going to remove this LED. Then I'm connecting this 220 ohm resistor in series with the capacitor, just like that. So the black wire is connected to the negative terminal, and the resistor is connected to the positive terminal, positive pin. Then I have two wires, this red and white, which is basically my multimeter probe, just to show the voltage across the capacitor. It shows 1.7 volt. I just want to discharge completely by short circuiting. Here, now the capacitor is discharged and it shows like 20 some millivolt. That's probably an error from the multimeter because I discharged it completely. Okay, it's showing 0 volt. Now I connected this resistor in series. Let's charge this capacitor through this the resistor. Connecting a red wire to one end of the resistor, and ground, black wire to the ground, and red wire to the positive. So you can see the voltage is going up. 8, 9. So it took a little more time than the last time when we connected this capacitor directly to the battery. When we use a resistor, it took long to fully charge the capacitor. Now it's 9.29. Now what I want to do, I just want to remove this 220 ohm resistor. I'm going to put this 10K resistor. Let's see what happens. Before that, I just want to discharge the capacitor fully. I discharged. The voltage showing like few millivolts. I'm connecting the 10 kilo ohm resistor, just like before, in the series with the capacitor. I'm connecting these wires. The same 0.36 volt. I'm just discharging the capacitor fully. Now showing 0.0 volt. I'm connecting the battery to this capacitor, and let's charge the capacitor. Connecting ground to the ground, positive to the positive. You will see the voltage going up, but very slowly. 1.3, 1.8, 0.9. So it's still the capacitor charging, but it's charging slowly. It's taking its time to charge. So it will take some time to reach 9 volt or the voltage of this battery. So it took some time. Now it's 7 volt, and it will take a little bit time to completely charge the capacitor to 9 volt. So what we learned, if we put a higher resistor in the circuit, the capacitor will take long to charge. So this capacitor is 4700 microfarad, a high capacitance. What I'm going to do now, I'm just going to change this bigger capacitor with a smaller capacitor, like this one. This is 1000 microfarad, and this one is like 4700 microfarad. So what happens if I use this small capacitor in the circuit? Now we connected the smaller 1000 microfarad capacitor with the 1 kilo ohm resistor, and I'm charging. You can see it's charging much faster than 4700 microfarad capacitor. So it's going up 5 volt, 6 volt. So it's charging faster. So what we learned, if the resistance in the circuit is less, the capacitor will charge fast. If the value of the resistor is high, the capacitor charges slow. If the capacitance is high, like this one, 4700 microfarad, it will take long time to fully charge through the resistor. If we are using the same resistor, but we are using a smaller capacitor of capacitance, like 1000 microfarad, it will charge faster. So lesser the capacitance, it will take less time to charge fully. Higher the capacitance, it will take more time to charge. And the resistance is low. If the resistance is low, it will take less time to charge. And if the resistance is high, it will take a long time to charge. So what we're going to discuss about something called a time constant. Time constant is like a quantity which actually helps us to find out the time taken for the capacitor to charge in an RC circuit. Now we know this capacitor charged to 9.28 volt since we connected. So how long it took, like this 1000 microfarad capacitor charges from 0 volt to 9.28 volt. How long it took to charge? How we find out that time? For that we use time constant. So this is our circuit. We have the capacitor. We were using 1000 microfarad capacitor as we used. Then we connected a resistor in series with the capacitor. That was 10 kilo ohm resistor, and we connected one end of the capacitor to the ground or the negative terminal of the battery, and we applied a 9 volt to the other end. So when we connect 9 volt to the battery, this capacitor the current start to flow through the capacitor, through the resistor, and charges the capacitor. And finally, this capacitor will charge from 0 volt to 9 volt. Then what we want to find out the time taken by this capacitor to charge fully. For that, we use something called time constant. Time constant is usually denoted by T or Greek letter tau. Time constant is the product of the resistance in the circuit and the capacitance of the circuit. In this case, the resistance is 10 kilo ohm to the power of 3, that is 10 into 10 to the power of 3 ohm, multiplied by the capacitance. It is like 1000 microfarad. So 1000 microfarad multiplied by 10 to the power of minus 6 farad. So that will be 10 to the power of 3, 10 to the power of 3, 10 to the power of minus 6. That will cut off and we'll get 10 seconds. So that is the time constant of this circuit. But what is it? What's this 10 second means? So when a capacitor charges, the capacitor is not charging right away. It's not going from 0 volt to 9 volt at 0 second, not instantaneously. It's not going to the maximum voltage right away. So what it does, the voltage will go fast in the beginning, like that. Then when the capacitor get close to the voltage, the charging voltage of the battery, the voltage will across the capacitor will increase gradually, and eventually, as time goes, it will reach the maximum voltage. That's the 9 voltage here. After some time, okay, let's see, our capacitor reached maximum voltage at this time, at this t time, at this time t. So what is this 10 second? This is, if you look at this graph, this is an exponential function. Means the voltage across the capacitor increases exponentially with time, not linearly, like the time and the voltage. It's not going like that, like uniformly from here to here. Rather, it goes fast in the beginning, then after some time it just goes slowly, it increases slowly, and finally it reaches to 9 volt. So this 10 second is the time constant. This time constant means it is the time for the circuit to reach 63.2. Oh, am I right? 63.2% of the total voltage. So, which means it took 10 seconds. It will take 10 seconds to reach the 63.2% of 9 volt. So we have the circuit. If we want to charge this 1000 microfarad capacitor to the 63.2% of the 9 volt, we have to wait 10 seconds. So how long it will take to, say, fully charge capacitor to 9 volt? which is approximately, this is 99%, say 99, not fully, it never charged to full voltage, it will take forever. Say from the beginning of charging to 9 volt, it will take almost five times the time constant, approximately. So if for a circuit like this with 1000 microfarad and a 10 kilo ohm resistor, if we want to charge this capacitor from 0 to 9 volt, it will take approximately 5 times of the time constant, which is equal to 5 multiplied by 10 seconds, so it will take 50 seconds. So it will take 50 seconds to charge from 0 to 9 volt basically. And same with the discharging of the capacitor. See, imagine our capacitor is charged to 9 volt. Now that's the maximum voltage. When we put a load in the circuit or a resistor in the circuit, the capacitor will charge to discharge just like that exponentially. So what happens in 10 seconds, this capacitor will discharge the 63.2% of 63.2% of 9 volt, or it will reach 34.8% of the total voltage after 10 seconds. So that is time constant. Time constant is the resistance multiplied by the capacitance in the circuit. A time constant is basically the time taken by an RC circuit to charge the capacitance, the voltage across the capacitance to 63.2% of the total voltage, or the time taken by the capacitor to discharge 63.2% of the total voltage, or to reach 34.8% of the initial voltage of the capacitor. So that is all for now, and I hope you guys learned something. If you have any questions, just comment in the comment box, and if you learned something, give me a thumbs up or a like. And if you want to see more videos, subscribe to my channel. I'll be making more videos about electronics. And that's all for today. Thanks for watching. Bye.